Everyone thinks a 400W wind turbine means free off-grid power, but here's the thing, the Pikasola 400W can end up costing you more in wasted time and mediocre watts than you expect, because that 400W rating only happens in winds you probably never see. I tested this turbine for 30 days on a 30-foot mast and a rooftop mount, logged wind with an anemometer and tracked amps with a shunt meter, and what I found will make you rethink the hype. Low start speed claims, kinda. Real charging power in typical winds, not what the box suggests. But here's where it gets interesting, it isn't all bad if you use it the right way. Before we dive into what I discovered, quick heads up. If you're already set on grabbing it, I've put the best current price link below. But stick around, because what I learned about when this does and does not work could save you a lot of frustration. Look, here's the deal. I wanted a backup power source for a small off-grid setup at a cabin where solar drops off hard in winter. Night charging, windy ridgeline, it sounded perfect. I'd already tried a bargain turbine years ago that cooked its controller in a storm, so I came in skeptical but hopeful. The Pikasola's price, around $269.99, and mid-pack 3.7-star rating on Amazon made it feel like a safe experiment. The listing promised 2.5 ms, about 5.6 mph startup, nylon carbon fiber blades, a permanent magnet generator, and an aluminum yaw body that tracks wind. On paper, great. In the real world, I wanted to see if it could reliably push charge into a 12V battery bank on breezy winter nights without becoming a roof siren or a decorative spinner. Unboxing and assembly first. Everything was there. Hub blades, tail, nacelle, basic controller, hardware. The blades measure about 23.8 inches each, giving a rotor a little over a meter across. Assembly took me about 45 minutes, but the instructions were thin. Pro tip, dry fit then Loctite. Mount requires a pole, I used a Schedule 40 steel mast. Out of the box, the balance was close, but I still added a bit of tape to tame a tiny wobble at higher RPM. So far, so good. Quiet at low speed. But then I wired up the controller to a 12V Li-Fi PO4 bank and took it to the roof for a quick test. Low wind behavior at 6-7 mph, the rotor spun, but the system barely moved the needle. At 8-10 mph, I started to see trickle charge. 0.20.8 amps, roughly 310 watts at around 13V. Yes, it starts spinning early, but real charging took more wind than the listing makes you think. The upside. Vibration was low and noise was a soft whoosh, rooftop friendly. But then I put it where wind actually matters, a 30-foot mast in a clear, open area, moderate wind test. In sustained 12-15 mph winds over 3 separate days, output climbed into the 35-70W range, with occasional peaks around 90W. That's 3.5 amps into a 12V system, respectable for the size but not mind-blowing. I logged about 8 hours of these conditions and the average settled near 45W when the wind was steady. The yaw system did a decent job tracking direction changes and the body felt robust. But then the first storm front rolled through, gusts 18-25 mph, finally some punch. I saw short bursts between 120-200W, with the highest sustained minute at about 160W. The controller's brake function occasionally kicked in as gusts pushed RPM up, which kept the system under control. Noise increased to a noticeable whistle but not unbearable. Picture a box fan on high 2 houses away. Still no 400W, and to be fair, that's expected. Most small turbines only hit rated power at around 25-30 mph airflow, but here's where it gets interesting. Rooftop turbulence test, I moved it back to the house roof to simulate typical buyers. In uneven, swirly wind near trees and ridgelines, average power cratered. I'm talking under 10W most of the time, maybe 30-40W in random gusts. The takeaway. Mounting height and clean airflow are everything. Put this on a short pole behind a chimney and you'll be disappointed. Period. Here's the most surprising thing I discovered. Energy yield, not peak watts, is what matters. Over a breezy 24-hour period at the mast site, I logged 150 300 watt-hours. On a turbulent rooftop, I struggled to hit 50 Wh in a day. For comparison, a single 200W solar panel on a clear winter day gave me 400-700 Wh. Now, wind does run at night and in storms, that's the whole appeal, but you need a legit wind site to make it worthwhile. I spent 30 days testing in calm and stormy conditions, and the pattern held. The Pikasola can contribute useful trickle power in steady wind, but it won't be your 400W workhorse unless you live where average wind speeds are high and clean. The other revelation, the included controller works, but it's basic. It's more like a PWM brake protection unit than a high-end MPPT. It kept things safe, but I suspect a better controller and a taller mast would squeeze out more energy. Build quality overall is decent for the price, aluminum body, blades feel tough, but you're still in budget territory. If you want a small turbine that actually crushes in rough conditions, you're looking at something like a Primus Air 40, which costs several times more. Versus other budget 400W kits, the Pikasola is mid-pack, easier assembly than some, similar real output, similar limitations. The 2.5 ms start claim, spin, yes, charge not meaningfully. Now that you know the real story, decent and clean, steady wind, underwhelming on a roof, you can decide smart. If you're going to try it, grab it while price is still around that $269 mark. I've linked the best current deal below, or pair it with a small solar panel for a hybrid setup. Bottom line, don't buy the Pikasola 400W expecting 400W. Buy it if you've got a tall mast, clear exposure, and you want nighttime trickle power to complement solar. Tinkerers and off-grid hobbyists will like the price-to-earning ratio. RVers, urban rooftops, and anyone expecting plug-and-play 400W should skip it and put the budget into more solar or save for a higher-end turbine. For the right site, it helps. For the wrong site, it disappoints. Here's what nobody tells you. Wind is all about location, not labels.